Hi everyone. So in this video I want to just take you through a bit about tube bending, in particular on this tube bender that I've got, which is a manual bender. As you can see, it's a Model 3 bender from JD Squared. It's quite popular, this type of tube bender, style and mechanism, what I've used, quite popular with sort of home workshops and small workshops. It bends things really well actually. So at the moment I'm bending some roll hoops for my GT40 replica kit that's got to go out to some customers. So I thought I'd take you through how I do it, and then a few things that I'm not overly happy with the tube bender, how I've got round them or how I intend to get round them in the future, and a little bit about how I establish where bends need to start so that you end up with the correct finished product. So first of all, I'm going to take you through how I draw the tubes out. So this is a drawing that I did on my CAD. Right, so the first thing to note when you're drawing these tubes out is you need to know what radius the bending tools are that you've got, and that's on this particular model, on the smaller part of it. You've got this, so it tells you what tube diameter it is. So in this case, this sample tooling I've got here is 1.5 inch, because it's American, it's all in imperial, and it's 5.5 inch radius, and it tells you what hole on the machine it's got to go into. So you need to make a note of that while you draw the tube. So as you can see, 5.5 inch radius. Okay, so this is the drawing I ended up with on my CAD. So basically what I've done is I've drawn the end result shapes that I want with these radiuses being the centre line of the tube, centre line of the tube radius being the radius of my tooling that I just pointed out, in this case 5.5 inch radius. And then what I need to do is, from the end of the tube, I need to know the start point of each of these radiuses. And so what I've done is I've measured that on the CAD, and I've given myself some notes down here. So this is the overall length of the tube. So that's how long I cut everything off of the sort of 6 metre length that comes in from the supplier. I've then, because this has got 4 bends, so I bend a 20 degree from 100 millimetres, so that point there is 100 millimetres from the end of the tube. I then mark another bend point at 538 millimetres. So 538, 538. And on that bend, I'll be bending it 58 degrees. Okay. So the next thing to do is to put the tube, what I do is put the tube in the machine so that it holds it, so that I can mark it. Right, so with a marker pen and a tape measure, I'm first of all going to mark those 100 millimetre and 538 millimetre steps on this unbent tube. Okay, so as you can see, I've got my mark here and here. So that's where my form tool, or that will go up against my form tool. So this mark, when I'm ready to bend, needs to go up against this face of this part of the form tool, because that's where my first task with this, as you can see, I've already bent half of this rolled tube. So my first task is to line the first bend up with the form tool and get the roll hoop in plane with the formers. So that's the first bend lined up with its mark. It's very difficult to see on camera, and it's actually very difficult to see in real life, but I can just make out that the mark is against that start point of the former. As you can see, if I now don't get the first two bends in plane with the forming tool, I'm going to end up with a twisted roll hoop that won't be flat. So the way that I counter that, I think a lot of people do it by eye, but it's just not good enough. They end up being twisted too often. So the way that I do it is to use a straight piece of bar off of the top of the forming tool, and then judge this gap to the top of the tube so that I know that it's as flat as can be before I start bending. So that's got the roll hoop flat in the plane of the forming tool. Now I'm going to tighten the clamp onto the tube so that it can't move. What I've done, so this is my first of my little tips. If you pull the arm tight against the tube, it will hold it well enough to help you position and align the tube before you need to tighten that. Before you need to tighten that screw, at which point the tube's clamped ready for bending. If you're not familiar with the bender and you're looking at potentially buying one, I'm not sure all of them come with the protractor. I think it might be an optional extra. It's well worth having, because obviously it allows you to judge the bend that much better. It's not 100% accurate, and I'll go through that, why that is, in a little while. You just need to make sure that when you're at zero bend like this, so you've got a little bit of initial tension on the tube just to clamp it, and know that you're at your start point. If your indicator needs to be at zero, you can set your indicator either by bending the wire, or under here is a nut that you can release and swing the protractor. So the next thing to do is I'm going to bend my 20-degree bend as per my instructions. So that's the 20-degree bend done. So as you can see with this machine, it acts like a ratchet. basically got a very long arm, a very small lever on the sort of pulling arm, acting against a very long lever on the tool die to give you obviously the power to bend such a big tube. Now, in that case, I think that took me, it takes on this tube about 2 full pumps to get 20 degrees. I just did it in smaller increments there, and it took me 3. But the amount that the amount of sort of spring back that you get, and therefore the amount of pumping that you have to do, or strokes that you have to do is perhaps a better word, will depend on the material size, and the radius that you're trying to bend. So there's quite a lot of variables. So if you need something to be pretty accurately bent, and it's a new material to you, you're going to have to do some sample bends and figure out how much spring back you get, because that will determine how much effort you have to put in and your setup and whatnot. On this particular tube you don't get a lot. On the bigger tube that I do, I get quite a lot of spring back. Okay, so that's the sort of fundamental principles of bending using this type of bender. I would just like to go through some of the problems that I've had with this bender and some of the solutions that I've come up with, or some of the ideas I've got for solving the solution. So go through some of the problems I've got, some of the solutions I've found, and some of the ideas that I've got for solving the other ones that currently I haven't figured out a solution for. Right, so the first thing that happens, if you can see in here, is that due to the load on it, and it's just basically a laser cut hole in a piece of mild steel plate against a big boss, you get a lot of wear. So I now have lots of slack in my action, my ratchet action, which does cause a problem when you're trying to bend like large angles on big bits of tube. You get a lot of spring back, and the slack is enough to cause a problem of getting between two teeth on the ratchet. So that's something that I haven't solved yet, but I think it's going to be, I need some sort of better bearing arrangement, maybe an oiled bush welded in here against a hardened shaft or something. And originally this arm comes like this, so 2 laser cut plates flattened and welded together, over which you're supposed to put this light gauge box section to give you the sort of arm to pull with, but as you can see, the forces required for bending tubes are quite high, and it makes a real mess of this bit of tube. So, and it's all sloppy and slack, it's not very good. So I've welded a ring on of a heavier gauge, bit of roll cage tube, and I now use a smaller bit that's a nice fit that goes in there of round tube, and I find it's a lot better. I don't end up damaging the tube as I pull it. So I'd recommend making that sort of a modification on yours if you've got one of these, or get one. Okay, so another little modification I made is the introduction of this spacer that this ratchet arm can sit on, like so. It's just because this ratchet arm is so floppy, and it was floppy even before the large amount of wear occurred in there. It's nice to have it sat square, you're not pushing down at a funny angle. And another issue that I've sort of temporarily solved, as you can see, I put some spacers in there. And they're not actually underneath the tool now. You can see there's a gap underneath the tool. But when you release the pressure, there's no gap on. There's a reduced gap. It's got a little pin in it, but it's not high enough up, such that there's lots of play in the mechanism, and all jams up against itself. You see, it won't go back fully. It's a bit of a pain. So in an ideal world, I'd have a spacer underneath this main part of the tool, and I'd resolve either by pushing that split pin down, if you can just see that there, or not all of my tools have got that split pin, putting the spacer in underneath. Spacer in underneath this block so that everything's centered. It's not necessary, it's not super necessary, but as you can imagine, handling long bits of tube, trying to set them up sort of millimetre perfect, in position and everything, when you really want everything to move without jamming up, becomes a real problem if you've got to lift stuff up and whatever while you're fiddling about. There was something else I wanted to point out. Just in general though, this is how the bender's set up. So we've got this clamp arrangement that wraps around the tube and locks off with this big bolt. The forming tool has got a note on it that says hole 6, and you've got a hole 6 here, so that you know that this is where that's got to fit to get your 5.5 inch radius. Oh, the other thing I was going to say is, as you can see here, I've pretty much hit 20 degrees, but the spring back in the material means that when I have to go further than 20 degrees for it to spring back to 20 when I release the pressure on the arm. And that's what I was trying to say is dependent on the material, the radius you're trying to bend, the size of the tube, that sort of thing. So you have to sort of practice how far past you go in order when you come back you've hit the mark that you really want. And one thing I would say about this protractor is I'm not convinced that it's particularly accurate. I find that if I bend to 90 degrees, it's over 90. So I'm ending up bending to around about 88 degrees in order to get what measures to be a 90 degree bend. But I think we'll forgive them a couple of degrees over that sort of spread, given the usefulness of the machine. But it's just something to bear in mind. It depends on how accurate you want to be. Tube bending is an art in itself, and I don't profess to be an expert. And with these sort of machines, you do have to realise quite how accurate or inaccurate you're going to end up. But it's good enough. You can get by it, and they're certainly close enough for all of the applications that I use it for. So I'm going to 58 degrees on this one, but as you can see at the moment, it's on approximately 50 with tension on it. If I now let go of the tension, it's come back to about 45 degrees. That gives you an indication of how much spring backs in this sort of material. So I've ended up at about 59 degrees, but that's fine for me. I do find that these things often when they come to fit them on the car have relaxed a bit, so I think they do spring back over time. Okay, so that's pretty much everything required that I wanted to talk about with this tube bender. I am impressed with it, and for the money. I mean, it's probably a little bit too expensive for most people to have in their garages. But it's cheap enough that for workshop use, for occasional workshop use, to get one, and they are a phenomenal tool. Just show you the sort of bend that you get. See, it's nice. It doesn't flatten it at all like the horrible cheap hydraulic benders that you see. It makes a really nice, professional roll cage type bend. So if you liked the video, found it useful, please click the thumbs up, and if you want to see more of this type of video, press subscribe to the channel and you'll get notifications when I do new videos. Until then, thanks for watching.